This video is the last video on gross premiums from contingencies in actuarial mathematics, and I'm focusing on calculating premiums that satisfy probabilities. So these are percentile premiums. The other way to calculate premiums is using the equivalence principle. Okay, so the way I thought that would be best to explain this to you is by actually doing it with an example and explaining the steps as I go through. Okay, so here's the question. It comes from IFOA's CT5 paper, April 2013, and I'm going to walk you through the solution, but first let's read the question, understand what's going on. A life insurance company issues whole life assurance policies to lives aged 50 exact for a sum assured of £75,000, payable at the end of year of death. Premiums are payable annually in advance. Calculate the minimum annual gross premium that the company should charge in order that the probability of making a loss on any one policy would be 10% or less. The basis for our calculations is the following. Okay, so we have mortality, select mortality here, that's very important, interest rate 6%. Then we have initial expenses and initial commission 100% and £325, and then renewal commission 2.5% and £75, and these percentages are of the annual gross premium. And then note that for these renewal commission and renewal expenses that they start from the beginning of the second year. Okay, so each premium excluding the first year. If premiums are paid annually in advance, then we exclude that first premium, so it starts at the beginning of the second year, which is the exact same as these renewal expenses. Okay, so step number one for us in order to answer this question is to set up the gross future loss random variable. Now, they didn't explicitly ask us to do this, which could have been a question that preceded this, but they weren't kind enough to do that, so we've got to do it ourselves. And this is a crucial step. We can't skip this step. Okay, so let's zoom this in now so that we can pay attention to what I'm writing. So this gross future loss random variable, I'm going to denote L. L is equal to, now this is, since it's a loss random variable, this is outgoes minus income. Present value of outgoes minus present value of income in terms of our lifetime random variables. So that's curtate future lifetime random variable, that's capital K, and complete future lifetime random variable, capital T. Okay, so this gross future loss random variable equals to 75,000 times by V to the K50 select plus 1. Okay, so this represents my sum assured amount, the present value of my sum assured amount that pays at the end of the year of death. This is a whole life assurance policy. 75,000 is my sum assured, and this present values it by the whole number of years of life that this person has left, plus that end year in which they die, because I pay them at the end of that year. So I've got to add that one there. Okay, then another outgo that I have is 325, which is this initial expense here. Then the second or third outgo that I have is this initial commission amount, which is 100% of the annual gross premium. So I'm going to call the annual gross premium P. So this is plus P. And then I also have to deal with these outgoes here, the renewal commission and the renewal expenses. Okay, so the renewal commission and renewal expenses I have to represent with an annuity. Reason being is because they start at the beginning of the second year and they will continue until this person dies, because this policy will be renewed until they die. This policy terminates on this person's death because it's a whole life assurance policy. Okay, so the annuity that I'm dealing with is an annuity for K50 50 number of payments, and this is an annuity in arrears. Now, the reason why I do this is because an annuity in arrears that starts in the first year is the same thing as an annuity that starts at the beginning of the second year, because the end of the first year and the beginning of the second year are at the same point in time. So it's okay to do this. I could have otherwise done an annuity in advance for a person aged K50 plus 1, and then I would have had to have discounted in terms of probability and in terms of the time value of money. And you can see that this is more complicated, so I just go for this one. Okay. Now, the amount that this annuity will be paying every year will be £75 for the renewal expenses. So that's 75 plus this 2.5% of each premium. Okay, 2.5% of each premium is 0.025p. Okay, so these are all the outgoes, the present value of all the outgoes. But I also have to take into account now the present value of my income, which is my premiums that I will be receiving as the insurer. Okay, so gross future loss, random variable. Loss means outgoes minus income, because profit would have been income minus loss. Income minus expenses, income minus outgo. So the reverse of profit is loss, and so I must reverse that calculation. Okay, so now I subtract my income, which is my premium that I'll be receiving at the start of each year. So this is an annuity in advance, and the annuity is for K50 plus 1. Okay, why is that the case? Well, because if this person lives for the next 10.5 years, I will receive a premium at the start of the first year, the start of the second year, the start of the third year, etc., etc. So I'll receive 11 premiums from them because they die in that 11th year, and I receive the premium for the 11th year at the start of the year. Okay, at time 10 is the beginning of the 11th year. Okay, how do I know that? Because the beginning of the first year is time 0. So the beginning of the x plus 1th year must be time x. Okay, so here's my gross future loss random variable, and that's just the first step done. First step done, now we move to the second step. Well, the question was asking us to calculate the minimum annual gross premium that the company should charge in order that the probability of making a loss on any one policy would be 10% or less. Okay, so what I'm interested in here, this is step 2, is the probability that this loss random variable is greater than 0. In other words, the probability that I make a loss, the loss random variable being greater than 0, represents a loss. This must be, now the probability of making a loss on any one policy should be 10% or less, is less than or equal to 0.1. Okay, that's me setting up for these calculations now. Okay, but from here, I can't actually go and do anything. What I really need is, from this, if I want to calculate the premiums, what I'm going to end up needing is I'm going to end up needing Ks, these K50s, okay? And I'm going to need a value for L. So from here, I need to move to something that I can work out better. Now I want the minimum annual gross premium. So I want the gross premium that's on the borderline of this. Okay? That means that I'm taking the gross premium when this equals 0.1, when this equals 10%. So what I'm actually dealing with here is the probability that the loss is greater than 0 is equal to 0.1 in order to calculate my premium. Now, this event that I make a loss can be expressed in terms of these K's and T's that I'm trying to find. Okay, more explicitly in terms of T's, but T's and K's are related, so I'm going for T's here. Okay, the T being the complete future lifetime, K quotate future lifetime. Okay, so if I make a loss, let's understand that in terms of the complete future lifetime of this policyholder. So if this person makes a loss on the whole life assurance policy, so if the insurer makes a loss on this policyholder's whole life assurance policy, what does that mean for us? Does that mean that the policy ends early, or does that mean that the policy ends late? Well, let's think about it. I am receiving premiums, and then at the end of the day, I'll be paying this 75,000. So the more premiums I receive, the greater my income. Okay, so if I end up receiving a lot of premiums, then I'll probably make a profit. So if I end up receiving a small amount of premiums, then I will make a loss. Okay, now the loss being greater than 0 then is synonymous. So this event, that the loss is greater than 0, is equivalent to the event that my complete future lifetime is less than some time t, which I need to find out. Okay, why is that the case? Well, if my loss is greater than a certain amount, being 0, I must make a loss. That means that this person must die before a certain point in time in which my policy then becomes profitable for the insurer. Before that point in time, it's not going to be profitable because I wouldn't have accumulated enough premiums to account for all the outgo. Okay, so before that point in time, I make a loss. So when the complete future lifetime of my policyholder is less than some amount, I will make a loss. Okay, so if that's true, then I can rewrite this equation as the probability then, I just change this event inside, probability that T50 less than T is equal to 0.1. Okay, so what then is the probability that the complete future lifetime is less than T being equal to 0.1? Now, this is the probability that the person dies within T years. Okay, this is the same thing as saying 1 minus the probability that he survives. So I then just manipulate this and I get to the probability that T50 is greater than or equal to T equals to 0.9. Okay, so the inverse of that is this, and the inverse of 0.1 would be 0.9. Okay, so 1 minus this and 1 minus this. That's all I did. Alright, why did I do that? Well, because I wanted to work in terms of probabilities of surviving. I could have done it in terms of probabilities of death, but it's much easier to look for L's and P's in my life table than it is to look for L minus something, and I have more things to work with. So it's just easier to move it into this form. Okay, so how do I represent this in terms of things that I can find on the life table? Well, this equals to L50 plus T over L50, and that should be then equal to 0.9. Okay, so if I wanted this probability to be less than or equal to 0.1, then what I'm actually wanting is where this is greater than 0.9. Okay, why is that the case? Well, if I'm in the 0.1 region, I must be less than or equal to 0.1. So 0.1 or less. That means when I take the inverse, it mustn't be 0.9 or less. I must still be in that 10% portion, so 0.9 or greater. Okay, so this should be greater than 0.9. Okay, I hope that's clear. If it's not clear, leave a comment and I'll try and tend to it. Okay, now if I manipulate this, I get to L50. Remember, I'm trying to find this t here. L50 plus t being greater than or equal to, sorry, just greater than 0.9 times by this L50. And this L50, you look it up on the AM92 select tables. It's 9,706.0977. Okay, that means that L50 plus t should be greater than 8735.488. Okay, what do we know? Well, we know, if we look at our tables, that L65 is equal to 8821.2612, and we know that L66 is equal to 8695.6199. Okay, 8735 sits between these two values. So all I did was I knew that L50 plus t must be greater than that. And I know that this, I went to look in my life table and saw between which two L's does this sit between, and it sits between these two. So the important thing here now becomes the 66 and the 65. It sits between those two. Okay, so that means that this t lies between, t is between 15 and 16. Why 15 and 16? Because 50 plus 15 is 65, and 50 plus 16 is 66. Okay, so t lies between 15 and 66. What was t? Well, t was where t50 had to be greater than or equal to t. Okay, now if t lies between 15 and 16, then this borderline point, okay, this borderline point where it starts becoming profitable is where the complete future lifetime is somewhere between 15 and 16. Okay, if my complete future lifetime where it becomes profitable is somewhere between 15 and 16, then that means that my curtate future lifetime is the whole number part of 15 point something. The whole number part of 15 point something is 15. Okay, so I say therefore K50 is equal to 15. And now I'm on the home stretch. Now all that I have to do is calculate my premium. Okay, so I need the minimum premium such that L equals 0. Okay, why do I need that? Well, I need the point where this starts to make a profit at a 10% probability level. So I've accounted for the probability already. I found that the 10% relates to when K50 equals to 15. Now I need to calculate the premium where this is the nick point. This is the point where it starts to become profitable. Where does it start to become profitable? Where it breaks even, where the loss is equal to 0. Okay, so that means that my loss equals to 0. I substitute in, for all of the k's in this formula, I substitute in 15. So it becomes then L equals 0 equals 75,000 V to the 16, because that was 15 plus 1, plus 325 plus the premium plus my annuity for 15 years. That annuity gets multiplied by 75 plus 0.025 times by the premium, and this I subtract off the premium times by annuity in advance for K plus 1 years, 15 plus 1 years, 16 years. Okay, now it's a matter of finding values for these present value factors, and it turns out that this V16 is equal to 0.39365. It turns out that this A15, this annuity in arrears for 15 years, equals to 9.712254. Turns out that this annuity in advance equals to 10.712254. And then I can calculate P because I have an equation of one variable, and then I have, when I solve for P, it is 3, this is pounds, 3,229.03 pounds. Okay, and that is the question solved. Now let's quickly recap how I did this so that we can understand the steps. Let me clearly delineate it for you. Okay, so we started off defining the gross future loss random variable. Very important. Okay, from there, we said this question is asking us for the probability of making a loss being no more than 10%, 10% or less. So I write that in terms of probabilities. Okay, then I change the event to be something that is going to be useful for me. So in terms of time, so that I can then sub in something for these Ks. Okay, and I found that that's the same. So from there, I wrote it out, and the nick point where this starts to become a profit or a loss, the point that I'm actually dealing with to calculate this exact T is at the 10% point. So at the 10% point, I rewrite this in terms of survival probabilities, just so that I have less to deal with. I can simplify it, and then I rewrite this in terms of life table things that I can go and find. Then I'm trying to find this T in here, so then I go and I expand this, substitute in the life table value for L50, and then L50 plus T must be greater than a certain number, which means that I need to find the two L's that lie on either side of that. So I go find those, and then that means that if L50 plus T must be greater than those two, my T must sit between 15 and 16. Okay, so I find where T lies. What does that mean for my curtate future lifetime? Because at the end of the day, all of the things in here are curtate future lifetime. So I need to go and find something, what this means for my curtate future lifetime. What it means for my curtate future lifetime is if my complete future lifetime of this policyholder is between 15 and 60, my curtate future lifetime is 15. Okay, then I go substitute it in and I solve for my premium. Simple as that. If you have any questions, leave it in the comments down below. Thanks for watching.